Hi, I'm Daniel.
The purpose of this experiment is to grow sugar beets in an agronomic production system while using advanced subsurface drip irrigation techniques and learning methods of agronomic research using high-tech equipment and materials.
Our experimental plot was 30 rows of sugar beets with rows spaced 30 inches apart. Subsurface drip irrigation tape was installed in each row prior to planting, with emitters at 12-inch spacing. The water moisture sensors were arranged in a grid where half of them were placed directly under the row at 1, 2, 3, and 4 foot depths, and the other half were placed at the same depths in between rows, as illustrated by this schematic. Soil temperature was also monitored with this setup.
Prior to seeding, subsurface drip irrigation was installed using a tractor with GPS in order to ensure precision and uniformity. After the drip tape was installed, the field was leveled by rolling. Finally, the beet seeds are planted to precision specifications using the seeder.
After laying out the main PVC pipe, we then installed each row's drip tape to the main pipe using saddles and glue. When we ran water through the irrigation system for the first time, we found leaks and other problems with the installation that needed to be fixed.
Getting down and dirty there? Wow.
After the beet seeds were planted, the field was irrigated twice a week and left to grow.
During our experiment, we tested two methods of weed control for comparison. One was the application of the herbicide Roundup, and the other was using a cultivator to mechanically remove weeds in between the rows. We cultivated the 10 rows of sugar beets that had any surviving plants and applied Roundup to the 5 of those rows.
We measured soil bulk density using two core sampling methods. And the compliant cavity method.
Measure the volume of water in the headspace. Then you dig out a portion of soil.
We recorded the biomass of our sugar beets over the course of the quarter to monitor its development. The results are shown in this chart.
To test nutrient levels, soil and petiole samples were taken. A petiole is the stem that attaches the leaf. We took soil from different sections of the field, combined them, and sent them to a lab. Similarly, 20 plant petioles were collected and sent off to the lab. Having nutrients in the soil does not ensure that they are available for plant uptake, so it is important to check that plants are adequately receiving them.
When we started counting the beets, they had already reached their maximum emergence. As the chart indicates, from this point forward, the stand count declined until no beets survived.
During our experiment, we encountered many procedural difficulties. And adverse weather.
Additionally, there were circumstances which resulted in the loss of the majority of our sugar beets. The possible causes were due to potential compaction, pre-existing herbicide residue, or inadequate nutrient availability. One factor that was certain was loss of vegetation due to herbivory.
Regarding weed control, the section that received a Roundup treatment had no remaining weeds. On the other hand, the section that received cultivation had weeds that grew in between the sugar beets in each row. Some of our innermost rows that retained sugar beets also had significant weeds, indicating competition was not the cause of poor emergence and stand count, but rather herbivory and edge effects.
In conclusion, our experiment was a success. Although our crop failed, we were exposed to a number of practical skills in agronomic systems. It was the process of the experiment that mattered, not the outcome. Overall, we acquired the proper knowledge to begin our careers as a young farmer.
Here we have our professor's vehicle.
Come here, look at all the dirt.
This is exciting. True soil scientist.